So that brings us to the conclusion of our course. You survived Buildah, you survived Podman, you survived Kubernetes. That's something that you can like write on your resume that like I survived Kubernetes, right? You learned a lot of stuff about Docker, which is awesome. You learned what a container is. You learned how to handcraft a container, which is, again, what more than a lot of people can do that use containers every day. You learned what Docker is, where it can be useful, how to set up Docker files for both development and production, how to set up networks in Docker, bind mounts, volumes, Docker Compose, and then a great introduction to like the ecosystem at large, which would be like Podman and Buildah and stuff like that. The things that I think that will immediately help you as an engineer, as a developer, is how to make a shareable developer container. I think that's very useful. How to make that work with Visual Studio Code, which if you're a VS Code user will make that very useful for you right away. How to get up and going if someone gives you a container, right? Like if someone from your ops team says like, here's the container, now you know what to do with it, right? And then how to start smaller scale, like multi-container projects with Docker Compose and then eventually Kubernetes. I think those are like the key immediately useful takeaways. I think everything else is just kind of knowing the ecosystem around containers. And then I think containers are just going to become more and more important, right? Some of these like techniques that I've shown you are becoming more common at companies like Microsoft and Google, and I think that's going to permeate down into these smaller companies as well, right? So I think you're ahead of the curve if you've gotten this far in the course of like where the ecosystem and where the environment of the industry is going. And there's other things really cool that we didn't talk about, things like Azure Container Instances, AWS Fargate, Google Cloud Run, Visual Studio Online is another one that's really cool. And these are all things that are centered around containers. Like something like ACI, Azure Container Instances, or Fargate, or Cloud Run, what you do is you give the cloud providers like, here's my container, and then the cloud provider just takes in the container and starts running it. And then it'll scale it up and scale it down for you. They're serverless containers in that you don't have to manage them, you don't have to scale them or anything like that. Everything just kind of works. So definitely check those out. Those are a lot of fun. So I'm going to come in here to the notes, and we're just going to kind of go over some last like ecosystem things that you can go do more investigation if you're interested. So it's here in the conclusion section. So if you want more container runtimes alternatives to Buildah, Podman, and Docker, there's LXC and LXD. So LXC this also comes out of the Open Container Linux Foundation kind of projects. Docker used to be based on LXC, so it's kind of a fundamental building block. And so it's also based around containers. LXD is the daemon that runs in the background. The idea with LXD versus Docker is very much built for, I'm going to spin up and destroy containers, and I don't really care how frequently I do that, right? Nothing is meant to live forever. Everything is disposable. That's kind of the Docker way. With LXD, this is meant for containers that are going to be running for a very long time, right? And so these ones, you're going to spin up a container, and then you're going to go in and you're going to customize it, right? LXD is for Snowflake containers that you want to keep running for a very, very long time. Then there's Rocket, RKT, which is from CoreOS, and CoreOS just got bought by Red Hat, and Red Hat got bought by IBM, so IBM eventually owns Rocket. It's very much meant to pair with CoreOS, and it has the core idea of pods, and this is the exact same idea of pods to Kubernetes, where you have these like atomic deployments of like 5 containers that are all bundled together. That's built into Rocket, whereas Docker doesn't necessarily have a concept of pods, right? So if you have that idea, then Rocket's a good fit for you. It's also built into CoreOS, so if you're interested in that, then in CoreOS, then Rocket's a good fit for that. Okay, and so we talked about Kubernetes, which is an orchestration system. That's what you would call Kubernetes. It's a container orchestration system. There are a few others that you might want to be aware of as well. Docker Swarm, so built into Docker. In fact, if you come in here to close this down. If you say Docker Swarm like that, there's a whole bunch of stuff in here about how to initiate swarms. And swarms are comparable to Kubernetes, right? So you can have multiple containers being managed and like how they're managed with Docker Swarm. So I linked you there to the documentation if you're interested in doing Kubernetes-like things, but with Swarm. It's simpler. It's simpler, it's less powerful than Kubernetes. So I was actually very tempted to teach that too, because I think it's a better way to get started with it. But the thing is, people want to know Kubernetes, right? Like that's what everyone's saying. Everyone's very interested in it. So I decided to go down that path. But if you're interested in, I would definitely say check out Docker Swarm. On the other side of that is Apache Mesos. And Mesos is super hard. Like I can't even get it started. And I'm not even joking. I tried to get it started and I couldn't. So it's even more powerful perhaps than Kubernetes. I don't know if I can back that up, but it's as powerful as Kubernetes at least. But it's just very difficult to use. They've actually built a layer on top of it called Mesosphere, which allows it to be a little bit more simple to use on. And now there's another layer on top of Mesosphere, and the name escapes me. But it's layers upon layers of being very difficult to use. But it does the same thing where you can orchestrate complex applications with Mesos. Mesos came out of Twitter, right? So now all of Twitter's infrastructure is built with Mesos, whereas like Google invented Kubernetes. So they have a system called Borg, and they kind of exported that architecture, and that became Kubernetes. Internally inside of Google, they still use Borg, though, just in case you're wondering. So I guess Mesos was invented at Berkeley, and then Twitter adopted it. I think that's a more accurate way of putting it. The newcomer on the scene is a HashiCorp Nomad. I imagine many of you know HashiCorp. They did Vagrant, they did Terraform, they did Consul. They do a lot of tools that DevOps engineers really quite like, myself included. I think HashiCorp is a great company doing great stuff. And so they have recently come out with Nomad. And Nomad is much more limited than Kubernetes. Kubernetes does a lot of stuff for you, like load balancing and a whole bunch of other stuff, right? It does everything out of the box. It's meant to be the kitchen sink of orchestration tools. Nomad is just the orchestration part, and it is nothing else. So if you're into that kind of like that Unix methodology of like this tool does one thing and it does it super well and it does literally nothing else, Nomad is probably what you're looking for. So it's meant to pair with things like Terraform and Consul and Vault and all their various different tools together. Like for example, we didn't talk about Kubernetes does secret management, right? There's a secret management tool built into Kubernetes. It's not built into Nomad. They have a separate product called HashiCorp Vault, and that's meant to pair together with Nomad. So check that as well. People are liking it, so that's all I really can say about that. But I like and trust HashiCorp. Something that we didn't really talk a ton about is what is the host? What is running your servers in production, right? Now, sometimes you're just giving your containers to Azure and say, hey, Azure, execute this for me, right? In which case you don't care about what's running it because the cloud provider is choosing it and not you. But if you're running your own VMs and your VMs are executing your containers, you have to choose what the host operating system is. So there's one called CoreOS Container Linux. This is, or people just call it CoreOS. They don't separate out that Container Linux is different, but it actually technically is called Container Linux and is made by CoreOS. So it's a minimal Linux OS host. It's one of the most popular ones for sure. And it just ships with a bunch of tools that make it very simple to get started with containers. So that's a very popular one. I like Rancher OS. I started playing with it the other day, and it's a very strange operating system in a fun way that normally you have like Bash is like the PID1, like the first thing that execute. With Rancher OS, everything is executed by Docker. Everything is a container. So if you execute anything within Rancher, it's Docker that's doing the execution of it. So every single process is a container, which is really, really fun. So definitely give it a shot. There's one called Ubuntu. I think we've all heard of this, right? Ubuntu is really great at executing containers. I think they have a project that actually is meant, they have like a specific distribution of it. I can't remember what it's called. Snappy? Might be called Snappy, something like that. But you can also use Fedora, you can use Debian, any one of those Linux operating systems. They're not built for containers, but they're built for everything. But containers are part of everything, so it's a valid choice to think about using those as well. And then there's one out here that I wanted to call out called DCOS. This is strongly associated not with Kubernetes, but with Mesos. However, I am told that DCOS can definitely run Kubernetes as well, and it can be controlled. You can have Mesos and Kubernetes talk to each other, which just sounds like some sort of hell that I don't want to be in. But so anyway, DCOS, which stands for Distributed Cloud Operating System. It's very unique. And so it's people really like DCOS more than they like Mesos. I've never used it, so I'm not going to tell you anything more about it than that, but people like it. And then VMware Photon comes from the company VMware, which makes a bunch of tools that you probably already are using. They recently came up with their own container OS operating system called Photon. So it's meant to mostly pair into their other tools like vSphere and such. So I think we had some good questions from the audience. One of them I remember that are from the online crowd. One of them that they asked was, what's the difference between CMD and run? So let's go take a look at that really quick. Here in my Docker file, you can see here I have run and I have CMD down here at the end. One of these is done at runtime and one of them is done at build time. So run, this is going to get run as soon as I say Docker build, right? So you're going to do all the dependencies installing when you're building the container. And CMD is where you're telling Docker is like when someone runs this container, when someone does Docker run this, right? So this is at runtime. This is at build time. You're also very likely going to have multiple Docker runs, or you're going to have runs, and you can see here I have 3 runs in here, whereas you will only ever have at most 1 CMD.
Can this be set up with Gatsby as well, and those having a VS Code extension help set this up pretty easy, is the question.
Sure. So like we did Hugo before, could you do this with Gatsby? And the answer is absolutely, right? So if you had like a Gatsby project and you're working with a bunch of people that didn't know how to use Node and NPM and all that kind of stuff, you could totally wrap this up in a container and it would work just as well. My guess is that there's probably already a Gatsby container on Docker Hub that does the exact same thing. So yeah, for sure, you could definitely do that. Something I didn't really get into as much in here, because the person mentioned VS Code, is the Docker extension for VS Code. You can see here that it shows me all of my containers running. In fact, I can see here that my build a container is actually still running. And I can just say, you know what, I'm done with this, stop. And it'll just stop my container for me, just like that. And here I can come in and run. I can pull containers. Here's all my images that I've pulled, right? I can see that I have various versions of Alpine. I have various versions of NodeApp, Builda, CodeSmith. That's one that I built a while ago for our good friend Will Sentence, actually. So this is something worth checking out as well. So you can see I'm also connected to an Azure registry. Is that true? No, I would have to sign in, but you can connect it to Azure. You can connect it to Google or GitHub or all these things as well. Yeah.
Another question. What would be the best way to monitor and alert on containers going down at scale?
That is a good question. Like, what's the best way to monitor? There's a lot of products that do this for you. Like, you can go as far as using things like New Relic, which work really well, and they have specific things for containers. Each of the cloud provider has various different mechanisms for monitoring. Like at Azure, we have App Insights. I think it's CloudWatch for AWS. I don't remember what GCP's is called, but they all have their own specific incantations thereof. That being said, there are probably other tools. Like you can use things like StatsD and etcd, or not etcd, but rather StatsD for doing some sort of consolidated logging. There's a lot of different products out there. I'm not more familiar with any one of them than the other. Just there's also Sentry. Sentry would be a good one. So honestly, there's not much difference between what you would be concerned about versus what Kubernetes is doing versus what a normal web service would be doing. You're going to treat them relatively the same way for the most part. There's some specific Kubernetes stuff, and your cloud provider will probably provide that for you. All right, well, congratulations. This is a deeply technical topic, and hopefully it was presented to you in such that like you learned something about it. I had a lot of fun creating this course for you. If you liked it, again, a star on GitHub says a lot, helps me. Feel free to tweet at me, file issues, open PRs. I already saw someone open a PR last night, so I'm going to go merge that. So thank you for helping me make the best course possible. Thanks again to Friend of Masters and the whole crew. You all are the best. But like in the end, I think containers are going to be important tools for all of you, whether you write CSS, Haskell, or Node.js. Like it's useful to everyone, and I think going forward, you all are going to be ahead of that curve because you took this course. So thank you. Mhm.